Kimi K2.5 is 5 times cheaper than Kimi K3 on every single token, and at high volume, that gap costs you real money fast. 5 times cheaper is a number that changes your infrastructure budget conversation entirely. Both models just dropped, and the pricing gap is live right now, so I'm running Kimi K2.5 versus Kimi K3 across 5 tests to see which one actually earns your budget. What I couldn't figure out until the context test is whether that 5x price gap actually matters for your specific workload, and the answer might surprise you. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. And every number here is traced back to official pricing pages, model cards, and independent benchmark aggregators. Nothing invented. If you're running a high-volume coding pipeline pushing millions of tokens a day, picking the wrong model here costs you thousands of dollars a month. Test 1. Cost. The number itself is kinda wild. 0.60 per million input tokens for Kimi K2.5 versus 3.0 Ors for Kimi K3. And if you're pushing 10 million tokens a day through a coding agent, that's a $24,000 monthly difference, which is basically a salary. So this test isn't just a line item. It changes your whole infrastructure budget decision. I pulled the official pricing for both models, and what surprised me is how consistent the gap is across every tier. Kimi K2.5 runs 0.60 per million input tokens and 3.0 SAR per million output. Kimi K3 is 3.0 codes input and 15.0 output. And even on cash hits, K3 is 3 times more expensive at 0.30 per million versus K2.5's 0.10. So the 5x gap holds everywhere you look. Kimi K2.5 takes cost, and it's not subtle. I went in thinking maybe a 2x gap given the model size difference, but 5 times cheaper on both input and output is a completely different conversation, and that puts Kimi K2.5 on the board first at 1-0, which for any team running real volume might be enough to decide things right here. Test 2. Coding benchmark performance. Because a solo dev shipping a production agent on a deadline needs to know if the cheaper model can actually do the coding work, or if it collapses on the hard stuff, and K2.5 scored 76.8% on SWE bench verified, while K3 hit 88.3% on terminal bench 2.1. Though I want to be upfront that these aren't the same benchmark, which makes this comparison genuinely tricky. What jumped out at me here is the data gaps. K2.5 has a published SWE bench verified score of 76.8%, solid and sourced, but I couldn't find a published SWE bench figure for K3, which does have terminal bench 2.1 at 88.3% and frontier SWE at 81.2%. And bear in mind, these are different test setups, so it's not a clean apples-to-apples read. And SemGrep reported that K3's code security precision in real-world tasks was weaker than the benchmarks suggest. K3 takes the coding benchmark round because its agentic scores are genuinely higher where data exists. K2.5 holds its own on SWE bench, but K3's terminal bench and frontier SWE numbers pull it ahead on agentic depth, and that ties things up at 1-1, though the real-world precision caveats from SemGrep mean you should take K3's benchmark lead with some skepticism. Test 3. Speed. So, 34.9 tokens per second on the official Kimi K3 API is the number that jumped out at me. Because if you're running a coding agent that needs to iterate fast, slow output tokens kills your loop time and piles up latency in every single agentic step. And at scale, that's a hidden cost that doesn't show up in your pricing dashboard until it's already hurting you. I looked at the optimized provider numbers, and the gap is kind of wild. Bayesian reports 340 plus tokens per second for Kimi K2.5, while Kimi K3 on the official API runs at 34.9 tokens per second with a 4.34 second time to first token on top of that. And even Fireworks' optimized K3 endpoint only gets to 163 tokens per second. So bear in mind these are different providers, but the directional gap is pretty clear. Kimi K2.5 wins speed, and it's not a close call. I knew K2.5 would be faster, but a roughly 10x gap on the official API is pretty extreme. And 340 plus versus 34.9 tokens per second is a real bottleneck for K3 in any latency-sensitive workflow, which puts Kimi K2.5 ahead 2-1 and makes the 5x price gap feel even more one-sided. Alright, so Kimi K2.5 is ahead on cost and speed, but we've still got context window and deployment coming up. And those two tests could completely flip how you think about which model fits your actual workflow. Context, in particular, is where the gap between these two is the most extreme, and it's the test that decides whether the cheaper model is even usable for your use case. Test 4. Context and output limits. The day your model hits its context ceiling mid-task, truncating a 300,000 token codebase review, dropping half the file, hallucinating the rest. You lose the whole output and start over, and that's not theoretical. For large codebase work, context ceiling is the hard wall that makes or breaks whether a model is even usable for your job. What I found here is pretty clear. Kimi K3 runs a 1 million token context window, while Kimi K2.5 caps at 256K, which is a 4x gap. And for anyone working with large codebases or long documents, K2.5 literally can't hold the full context K3 can, though on the flip side, K2.5 has agent swarm mode with up to 100 sub-agents documented, and K3 has no published equivalent for that kind of orchestration flexibility. Kimi K3 takes context, and the margin is real, 4 times. The context window is a hard capability difference, not a preference, and K2.5's agent swarm mode is a genuine flexibility win, but it doesn't close a 750,000 token gap. So that brings us to 2-2, and now this whole comparison comes down to whether you actually need that million token ceiling. Test 5, deployment and modality. The objection I keep hearing is that both models are open source, so deployment should be roughly the same, and I get why people think that. But the hardware requirements tell a completely different story. K3 needs 8 B300 or MI355X GPUs to run self-hosted. And that's not a casual infrastructure ask, so for most teams that requirement alone changes the whole deployment math. I went through the model cards for both, and here's what I found. Both are open source, K2.5 under modified MIT, and K3 under its own Conquam. Kimi K3 license, K2.5 runs on VLLM, SGLong, and K-transformers, which are pretty standard setups. K3 requires 8 B300 or MI355X GPUs for self-hosted deployment, which is a major infrastructure commitment. And K2.5 also adds video input support that K3 doesn't have, since K3 is text and image only. Okay, so this is where it gets genuinely complicated. Both models are open source and both support vision inputs, so the gap is smaller than it looks on the surface. And if you're running on managed API endpoints, the hardware difference doesn't affect you at all. So the modality and license advantages K2.5 has are real, but they're not massive. And it really depends on whether you're self-hosting or not. Deployment is a tie. K2.5 has real advantages on hardware flexibility, but K3's open source availability and vision support keep it competitive enough that calling a clean winner felt dishonest. So both models earn this one, and that leaves us at 2-2 with one tied, which means the final call comes down to your specific workload. Kimi K2.5 wins on cost, 5 times cheaper on both input and output tokens, and it wins on speed at 340 plus tokens per second versus K3's 34.9 on the official API. It runs on standard hardware with a modified MIT license, so deployment is way more accessible. And it adds video input support plus agent swarm orchestration with up to 100 sub-agents that K3 doesn't document. Kimi K3 wins on context, 1 million tokens versus K2.5's 256K, which is a hard 4RX capability gap for large codebase and long document work. And it leads on agentic coding benchmarks with Terminal Bench 2.1 at 88.3% and Frontier SWE at 81.2%, plus a generous 100 and above per file upload limit and 2.8 trillion parameters for complex reasoning tasks. Power is the dimension that ties all 5 tests together, and the real winner on raw power per dollar is Kimi K2.5, because it delivers 340 plus tokens per second, solid 76.8% SWE bench coding scores, and 5 times cheaper pricing. But if power means raw capability ceiling, regardless of cost, Kimi K3's 1M context and agentic benchmark scores take that title instead. I went in thinking K3's new flagship status would make it the obvious pick for serious work, but the data landed differently. 5 times cheaper is the whole verdict. And if you need high-volume coding pipelines, fast iteration, and flexible deployment, pick Kimi K2.5 because it's the smarter buy for most workflows. But if you genuinely need 1 million tokens of context or terminal bench level agentic coding depth, pick Kimi K3 and accept the cost. If this comparison got you thinking about cheap coding agents, you'll want to check out the next one I put together. It's called Kimi Code versus Codex. Which cheap agent wins, and it goes deep on agentic coding tasks, where the price to performance math gets even more interesting. So it's right there in the sidebar, and I think you'll find it pretty useful after watching this one.